Hello and welcome to this video reviewing the transformation of functions and the order in which to apply transformations. This video is intended to be viewed after completing preview activity 1.8.1 in the text. So if you haven't completed that exploration activity yet, pause the video and come back later. Okay, let's summarize your findings from preview activity 1.8.1. We noticed that given a parent function f of x and the function y equals g of x equals a times f of x minus b plus c, that the real numbers a, b, and c change the function to a related function in special ways. These changes are called transformations. One thing we noticed is that the parameter b, the parameter added or subtracted inside the function, horizontally shifts the graph of f. More specifically, when b is greater than 0, the graph shifts right, and when b is less than 0, the graph shifts left. Similarly, the parameter c, the parameter added or subtracted outside the function, vertically shifts the graph of f. More specifically, when c is greater than 0, the graph shifts up, and when c is less than 0, the graph shifts down. Lastly, we saw that parameter a, the parameter multiplied outside the function, vertically stretched the graph, and when a was less than 0, the graph reflected over the x-axis, or y equals 0. Functions often behave like numbers. We know that the order in which we add, subtract, multiply, or divide numbers matters. So a natural question you might have is, does the order in which we apply these transformations matter? To determine if the order matters, let's look at an example. On the left, we see a parent function made up of two pieces, a linear function and a quadratic function. And we notice a sharp turn in the graph at negative 1, 1. In the middle is the same graph after applying three transformations in the following order. First, a shift left, second, a vertical stretch, and third, a shift down. Notice that negative 1, 1 has transformed to negative 2, 0. Compare that to the graph on the right. That graph was created by first a shift left, second a shift down, and third a vertical stretch. It's important to notice that the point negative 1, 1 has been transformed to negative 2 instead of negative 2, 0. Since changing the order of the transformations creates two different graphs, we can conclude that the order in which transformations are applied most definitely matters. Specifically, vertical stretches and reflections are always applied before vertical shifts. This is related to the order of operations. We apply parentheses first, think horizontal shifts, then multiplication, think vertical stretches and reflections, and lastly, addition and subtraction, think vertical shifts. So again, order matters when applying transformations. Vertical stretches and reflections must be applied before vertical shifts. In the next video, you will see how to actually apply transformations to a graph.